See, now we are discussing second chapter, electrostatic potential and capacitance. In first chapter, we have studied that if a point charge Q is placed, then electric field is produced around that point charge. The region in which the effect of the charge is prevailing means placing any other charge, force is acting on that charge, then we can say field is there. Now we are discussing another property of the electric field, electrostatic potential. Here field is due to single point charge, maybe electric dipole, maybe another system of charges, means maybe light distribution, maybe surface distribution, maybe volume distribution. Here we are discussing first what is electrostatic potential energy. For convenience, suppose we have taken a charge Q, this is positive at origin, and another test charge is brought from point R to point P in the electric field. We have taken test charge Q. Here for convenience, we have taken both positive Q and small q. Both positive. So electric field is radially outward. Now test charge Q is brought from R to P by applying another external force. But we have applied force on charge Q, which is equal to electric force at that point. At any point, force will be F equal to QE. That is electric force. But we have applied external force opposite to the electric force, and we are bringing from R to P. But force is variable. So we can calculate work required to be done in bringing the test charge Q from R to P. We have to calculate total work done in bringing a test charge from R to P. Now see, work done by the external force, which is equal but opposite to the electric force. Then suppose at point R, at point P, potential energy UR and UP respectively. When we are doing work against electric force on charge Q, this work will be stored in the form of potential energy of the charge. Whatever work done on the charge will be stored in what? Potential energy of the charge Q at that point. Now we are bringing point Q from R to P. So total work done, also we can write in this way, work done W from R to P, W from R to P equal to integration from R to P F external dot dr vector. Total work done is WRP equal to integration R to P F external force dot dr, which is negative of what? Integration R to P F electric dot dr. As we have discussed, external force is opposite to the electric force. Now this work done on the charge, test charge Q, already stored as potential energy. So we can say this is nothing but potential energy from R to P. If potential at this point is UR and here UP, then this work can be defined as or written as RP equal to UP minus UR. So this where we are doing work or bringing a test charge from R to P, that is nothing but difference of potential energy between 2 points. So WRP equal to UP minus UR, also we can say like this. But whatever work done stored in potential energy, from this point we can say potential energy UP minus UR means final minus initial. So potential energy difference delta U, UP minus UR depends only on first point, position of the points initial and final. UP is nothing but potential energy at point P. UR is nothing but potential energy at R. That depends only position. Suppose we thinking we are bringing charge Q from R to P in on this path, also on this path. Then from equation it is clear that it is also UP minus UR, means it does not depend upon the path of the work done. Path on which you are moving from initial point to final point, this path is not of importance, or we can say it is independent of the path, and this is the basic property of the electric field. Work done in moving a charge Q from one point to another point does not depend upon path, only depends upon initial and final position, and this is the basic property of the electric field. This can be proved by using Coulomb's law, and this conclusion gives that electric field is conservative field. Electric field is conservative field. Now second point, potential energy difference depends upon initial and final position. Means this is not a potential but potential difference or potential energy difference. But if we select or we are free to select any point in the electric field due to any type of charge configuration. Suppose we are taking another point at infinite, then at infinite potential is 0. Then we can say W infinite to P, W infinite to P is UP minus U infinite. But for infinite, if we are selecting U infinite as 0, means potential energy of the charge, test charge at infinite is 0, then we can say this W infinite P is nothing but UP. From this we can define what is UP? Potential energy of the test charge Q at point P. Means work done in bringing a charge from infinite to a given point P. So again, definition: work required to be done in a test charge from infinity to given point against electric field is known as potential energy at that point. Again, for any test charge, work required to be done in bringing a test charge from infinity to given point P against electric field for any type of charge configuration is known as potential energy of that charge at that point. Here W infinite P equal to UP. Here see, in our study, potential energy difference is important, not absolute value of potential energy. So we will discuss from this point or from this point UP minus UR means work required to be done. Potential energy difference between 2 points. Potential energy difference between 2 points can be defined as work required to be done in bringing a test charge Q against electric field from first point to another point. Potential energy difference of test charge Q can be defined as work required to be done in bringing a test charge Q from one point to another point against electric field which is already stored in it as a potential energy. So it is nothing but potential energy difference between 2 points. Now we are defining electrostatic potential. Electrostatic potential. Again, delta U, UP minus UR, or WRP, UP minus UR. Work required to be done in bringing a charge from one point to another point. but here against electric field. But electric force is QE, means it depends upon charge. It is a charge dependent function. So depends upon charge. But instead of Q, suppose we are taking unit positive test charge. We are taking Q as plus 1 coulomb. Then we can write here UP minus QR. Both are for the test charge Q. Depends upon charge. But we divide by Q. Then we can say it is nothing but UP by Q or minus QR by Q. Now try to understand this term. Work required to be done in bringing a unit test charge from infinite to point P. Second one, bringing unit test charge from infinite to point R. Now these both are for unit charge and that can be defined as potential at point P. So also we can write Vp minus Vr. As you know, this is nothing but potential as a difference. This is potential difference. So potential difference, suppose again we are taking test charge. So we can say here work done by Q can be defined as Vp minus Vr. Means potential is a difference. Again we are taking R at infinite, then it is nothing but Vp. So if point is infinite, other point is infinite, so again definition of electrostatic potential. Again try to understand, remember this point, this is the most important for entire chapter. Electrostatic potential means work required to be done from infinity to a given point against electric field is known as electrostatic potential at that point, Vp. Again definition. In bringing unit test charge, unit positive test charge from infinite to a given point in the electric field against electric field is known as electrostatic potential at that point, denoted by Vp. And as you know, Vp simply it is Up upon R, Up upon Q. Up is potential energy and this is charge. From this we can say unit of this quantity is joule per coulomb. Also in the order of scientist Volta, it is defined as volt. Means joule per coulomb is volt. and diameter formula of that one joule means m1 l2 t minus 2 upon a1 t1. So answer is m1 l2 t minus 3 t minus 1. Again, unit of electrostatic potential, work by charge means joule per coulomb per volt. Diameter formula joule means m1 l2 t minus 2 upon a1 t1. So answer is m1 l2 t minus 3 a minus 1 is diameter formula. Now see again, last we have defined electrostatic potential. Simply it is nothing but work required to be done in bringing a unit positive test charge from infinite to the given point in electric field against electric field is known as electrostatic potential Vp or V at that point. Now, see, this is the basic definition of this chapter. Now we are discussing what is the potential due to a single point charge. Electrostatic potential due to point charge. Suppose we have taken charge Q at OC. And we have to determine the potential at point P with position vector R, or distance is R. Again, we are discussing for single point charge electrostatic potential due to a point charge Q at point P with position vector R. As you know definition, potential at point P means we are bringing unit test charge, unit positive test charge from infinite to point P. So this is infinite point. As we have discussed, this work does not depend upon the path on which we are bringing the charge. For convenience, we are taking radial path, means on the same line, infinite to P. So it is actually positive charge is an infinite, and we are bringing from infinite to P. Infinite to P. Again, here force is variable, so we have to calculate the work by integration. So consider any point with position vector R dash. At that point, field is suppose E R dash. Then from this point, we are bringing towards point P by delta r dash. This is r dash. This will be r plus delta r dash. R dash plus delta r dash. So for a small segment, delta r dash work can be calculated as delta W is Fe into delta r dash. But Fe, force on a point charge, point charge means Fe at that point is 1 upon 4 pi epsilon 0 q by r square. But for position r dash, we can write 1 upon 4 pi epsilon 0 q by r dash square. This is the force away, so outward direction, and we have brought against the charge opposite to the field, so displacement delta dash. So work done is 1 upon 4 pi epsilon 0 q by r dash square into delta r dash. But delta r dash is negative, so this is negative. This is the work done during this small line segment. Total work can be carried out by taking integration from infinite to point P. So total work done, W is integration from infinite to P, or also we can write R infinite to P equal to Q upon 4 pi epsilon 0 1 upon r dash square delta r dash. Now see, here it is vector dot product, but both are on same line.